10.3 NTP 10.3.1 Time and Calendar Services. Before you get really deep into network management, the one thing that will help keep you on track is ensuring that all of your components are set to the same time and date. The software clock on a router or switch starts when the system boots. It is the primary source of time for the system. It's important to synchronize the time across all devices on a network because all aspects of managing, securing, troubleshooting, and planning networks require accurate timestamping. When the time is not synchronized between devices, it will be impossible to determine the order of the events and the cost of an event. Typically, the date and the time settings on a router or a switch can be set by using one of two methods. You can manually configure the date and the time, as shown in the example, or configure the network time protocol, which is the NTP. Over here, for router number 1, you use the command clock set, and then followed by the time, date, and the year. In this example, the time is 16 colon 01 colon 00. Is 1 minute after 4 p.m. on September 25th, 2020. And after you enter this command, the new time, date, and year has been set. As the network grows, it becomes difficult to ensure that all infrastructure devices are operating with synchronized time. Even in a smaller network environment, the manual method is not ideal. If a router reboots, how will it get an accurate date and a timestamp? There's a better solution that is to configure the NTP on the network. This protocol allows routers on the network to synchronize their time settings with an NTP server. A group of NTP clients that obtain time and date information from a single source have more consistent time settings. When NTP is implemented in the network, it can be set up to synchronize to a private master clock, or it can synchronize to a publicly available NTP server on the internet. NTP uses UDP port 123 and is documented in the RFC 1305. NTP networks use a hierarchical system of time sources. Each level in this hierarchical system is called a stratum. The stratum level is defined as the number of hop counts from the authoritative source. The synchronous time is distributed across the network by using NTP. This figure displays a sample NTP network. NTP servers are arranged in 3 levels, showing the 3 strata. Stratum 1 is connected to stratum 0 clocks. Now let's talk about NTP stratum levels. Let's begin with stratum 0. They are the highly accurate non-network time sources, such as atomic clocks and the GPS clocks. The next one is the stratum 1. They are the NTP servers directly connected to stratum 0 devices. They provide time to stratum 2 devices. And then the next one is the stratum 2. Synchronized with stratum 1 servers and can provide time to stratum 3 devices. And then we have the stratum 3 through 15. Each level receives time from the stratum immediately above it. And then we have the stratum 16. The device is unsynchronized and does not have a valid time source. This figure shows the topology used to demonstrate NTP configuration and verification. The external NTP server at 209.165.200.225 provides accurate time through the internet. R1 operates as both an NTP client and a server. So as a client, it is synchronized with 209.165.200.225. As a server, it provides the time to switch 1. And the switch 1, the S1 also operates as both the NTP client and the server. As a client, it synchronizes with R1. As a server, it provides the time to other NTP clients. So R1 and the S1 are connected through the 192.168.1.0/24 network. Each device further from the authoritative source has a higher stratum number. Now let's talk about the commands used for NTP. The first one is the show clock command. So before NTP is configured on the network, we can use the show clock command to display the current time on the software clock. So in this example, for router R1, you enter show clock detail, and the return message shows the current time, such as is 8:55, 10 seconds PM, and then UTC. This is the UTC time, Friday, November 15, 2019. The time source is user configuration. The next command is the NTP server command. In the global config mode, and then we can use the NTP server followed by the IP address command to configure the IP address as the NTP server for that device. In this case, that's R1. So in R1, in the globe config mode, you enter NTP server 209.165.200.225 in this example, and then end config. Next, you use the show clock detail to see the time source. It's indicated the time source is NTP. In this example, we are going to use the show NTP associations and the show NTP status command to verify that R1 is synchronized with the NTP server at 209.165.200.225. Notice that R1 is synchronized with a Stratum 1 NTP server at the address, which is synchronized with the GPS clock. The show NTP status command displayed that R1 is now a Stratum 2 device, which is synchronized with the NTP server at 209.165.220.225. So first, we enter show NTP associations for R1, and as you can see, it shows the address. It also indicates this is the GPS clock. After that, we enter show NTP status. It indicates that the clock is synchronized, and this is Stratum 2. The reference is 209.165.200.225. It also gives you detailed information about the timing. NTP server is another very useful command. We can use that to configure a router as switch NTP server. For example, on switch 1, in the global config mode, you enter NTP server followed by the router's IP, that is 192.168.1.1. So here we configure R1 as switch 1's NTP server. S1 become an NTP client and synchronize its clock with R1. There are a few important fields in the result. The asterisk means R1 is currently selected synchronization source. The tilde symbol, which means R1 was manually configured as an NTP server. 192.168.1.1, that is R1's IP address. 209.165.200.225, this is R1's own reference clock. The ST2 means R1 is operating at Stratum 2, so S1 becomes Stratum 3. When 12, the last NTP response was received 12 seconds ago. Poll 64, so S1 polls R1's every 64 seconds. Reach 377. The last 8 polling attempts was successful. The delay is 1.066. So this is a round-trip network delay in milliseconds. The offset is 13.616. This is the difference between the S1's clock and the R1's clock in milliseconds. The DISP 3.A40, this is the estimated maximum clock error or dispersion in milliseconds. Now we fire another show NTP status command for switch 1. So the output from that command verified that the clock on S1 is not synchronized with R1 at 192.168.1.1 through NTP, and the R1 is the Stratum2 device, and NTP server to S1. Now S1 is a Stratum3 device that can provide NTP service to other devices in the network.